Hello coders, this is AlgoVote 048E. In this problem we are going to discuss about the latest problem sum and or from CodeChef January Long Challenge 2022. So what is given in the problem statement is you are given two numbers x and s, and you have to create a sequence of numbers. In this sequence the summation of all numbers should be s and the bitwise OR operation between all the numbers in that sequence should be x. Then you have to tell what is the minimum length of that sequence you can achieve where these two conditions will be true. And also it is also possible that this kind of sequence is never possible to create. In that case we have to print -1. So if you see the problem statement sample input and output, the first sample says that the x is 13 and the s is 23. You can see the explanation tells us that the answer is 3 as 9, 9 and 5. If you cumulate these three numbers 9, 9 and 5, you will get the summation of 23, and the total bitwise OR operation value of these three numbers will be 13, and it is the answer for this test case, which is 3, and it can be shown that there is no valid array with length smaller than 3. And for the second test case 6 and 13, there exists no valid sequence, so that the sum can be 13 and the bitwise OR operation of the whole sequence can be 6. So what should be the approach for this problem? There might be a various approach, but I am talking about in which approach I have solved this problem. Before going to the deep dive of this problem, let me clear you some fact regarding this problem. Let's say I am talking about this test case. You have to create 23, right? And this should be the value of s, which is the summation of that sequence, and you have to create 13, which is the whole bitwise OR operation of that sequence. Now let's say you have to make sure that the bitwise OR operation of that value is 13. First of all, you have to make sure about this fact. So what if we just append this number as the first element of our sequence? It won't be a byte area, right? Just to make sure that this fact is going to be true. Well, let's add this number 13. So what is the binary value of 13? That is 1 1 0 1. Now focus on one thing, that's the main observation. You have added 13. After adding 13 you will add some more numbers, but you cannot add that kind of number further after adding 13 which has a set bit where the bit of 13 is false. I mean to say, you have added 13 where the first bit is 1, second bit is false, third bit is true, and the fourth bit is set. You cannot add any number where the second bit is true, but you can add any number where the first bit is either 0 or 1. That is allowed. Or here that the third bit it can be 1 or 0. It can be 1 or 0. But whatever you are adding, 1 or 0, but the total XOR is total OR operation value is not changing now, because if you add 1 here, the total OR operations first bit would be 1. If you add 0 here, it would be 0. It would be 1 also. But if you add 1 here, the total OR operation value would be changed, right? So you cannot do that. So this is the basic observation before I get deep dive into this problem. Now let's say we will totally discuss about this problem, this test case. Okay, so you have added 13, right? Now the total sum of your current sequence is 13, and total bitwise OR result of your current array is also 13. Now you have validated this condition. You have to work on this now, right? So you have to add 10 more numbers. You have to add more numbers such that the newly added number summation should be 10, so that 13 plus 10 can become 23, right? So you have to add some more numbers here so that the bitwise odd of all the numbers remain 1 1 0 1 and the summation of all those numbers become 23. As simple as that. So what can you add? I have just told that you cannot set this bit, right? So which kind of numbers you can add? You can set this bit, which will give you 8 because it is the 4th bit, right? You can add 4, which will give you this. You can also add 1. So if I write more simply, you can make this bit count, right? This bit will give you an amount of 8. You can make this bit count, which will give you 4. You can make this bit also count, which will give you 1. But you cannot add this bit or this bit. Why? Because if you make this bit count for 13, this bit is 0. It is just the previous lemma I just told you. You cannot make this set, you cannot make this bit count, right? You have to make only this bit count. You have only 3 numbers, 8, 4 and 1. You have to create 10 from these 3 numbers. Now the problem reduced to a problem of you are given some numbers. You have to make the summation of those numbers equal to some others numbers. So in that case, for the sake of this problem, you are given 8, 4 and 1. You have to create 10 out of these 3 numbers. Okay, I assume you have watched this video until now with full concentration. You have to make 10 from these 3 numbers, right? Okay, now let's say I will add 8. Let's say I will add 8 at any point. Let's say I am adding 8. What is the binary value of 8? 1 0 0 0. Now I am telling you I want to add another 8. Is there any other way possible left that I can add another 8 without adding a new number? No, because if I want to add more 8, then I have to add another number, right? Then if I want to add 4, I have added 4. Nice. If I want to add another 4, then I have to add another 4. So for the sake of this problem, I am given I need to make the summation is equal to 10. I have to take x amount of 8 plus y amount of 4 plus z amount of 1. Isn't this is the only problem they are asking? Isn't it the only problem we have to solve? So you can see this problem is totally different from this point of view where we are currently in. So we have to make a factorization in which we are given some number and we have to take some amount of those numbers to make a new value. So this is the value, and now we have to do it greedily. Why greedily? Because I just showed you that if I want to add 8, then the value is changing. If I want to add another 8, then the value is changing again. In that case, we have to take the minimum number of the maximum time we are using x, y and z. That means x, y and z, we have to take the minimum of the max of them. Why so? Because let's say you have taken 3 8. Let's say you have taken 3 8. So if you take 3 8, then the sequence would look like something like this, right? Okay, we have taken 3 8 here. Now we want to take 2 4. Let's say we want to take 2 4s. In that case, we can take 4s from here, right? We can take 4 from here. We can take 1 from here, 1 4 from here. Now if we want to take 5 1s, let's say we want to take 5 1s, in that case we had to take 1 from here, 1 1 1 1 and 1. So now you can see we have taken 8 3, 2 4s and 5 1s. So what is the value of this minimum of maximum of xyz? That is 5. We have to minimum this thing. Have you understood why I am telling this? So we have to take just this thing, and let me make it clear once again. We have to take the minimum of maximum of x, y, z or some other values there can be, right? You have to take the minimum of max of x, y and z and further one. We have to do this. So we don't know from which range the maximization begins. In this kind of problem, our common approach is binary search, right? So now we are getting into the code, and if you have understood up to now, the rest pieces you will get understood by the code, I guess. Let's say we are taking x and s as input, then we are subtracting x from s. Just we have told you, because we are just making sure that this thing is working. We're just making sure that this condition is getting true very first of all. So that's why I am adding the first number here. Adding the x, that means I am decreasing x from s. So now the required, now the new updated s is 10. Is it clear to you? Well, so now the s becomes 10 for sake of this test case. Well, after that, initially by default I am taking answer as infinity. Infinity here refers to long max. Here we are going to do a binary search. So we all know how binary search works. We are taking the low bound at 0 and high bound as the maximum number can be. For the sake of this problem, it can be up to 10 to the power 9. Well, while low is smaller or equal to high, we are taking mid. Mid is equal to low plus high divided by 2, and the remaining number we are taking in each iteration I am taking from s. Well, then now we will iterate from each bits. We will iterate from here to here. Well, we will iterate from the leftmost bit to the rightmost bit and check if this bit is set. If this bit is set, then we can build the other numbers by setting this bit or not setting this bit, right? So we have to check if this bit is 1. That's why we have taken this bit set of x. If this bit is set, then we are taking shift. Shift refers to this bit is giving me which numbers? This bit is giving me 8, right? This is 1 4 8. Well, this shift is giving me 8, then times is equal to the remaining numbers, currently remaining numbers, divided by this value, this shift. That means how many times minimum I have to append 8 to make 10. In that case, I have to append 8 minimum 1, because 10 divided by 8 is 1. Then after that, I am taking minimum of mid and the division. Why I am taking this? Because we are, while binary searching a number, we by default make a guess that in this number sequence, let's say is this sequence, we just, if this is the lower bound and this is the higher one, we guess that the answer exists here. In that case, we are just making a guess that this time is equal to the minimum of the mid and the times remain, and then we will decrease the s by times into shift. Now after decreasing all the remaining numbers, in that case we will decrease 8 from 10, then it will remain 2, then we cannot decrease 4 from 2, we can decrease 1, then the decreased number becomes 1. After that, that means we have added, let's say if this is the paradigm, then we have taken 13 and then we have taken this, we have taken 2 1, right? We have taken 1 here and we have taken 1 here, then the rest bit will be 0. So for making 23, you can now see the number becomes as follows. I am writing it clearly here. Now the number is, now the 3 numbers I am taking is 0 0 0 1, then 1 0 0 1, and the base number, that is our x. Now you can calculate. The total XOR would be 1. The total OR would be equal to x, and the total sum would always be equal to s, because you can see this is 1, this is 9, 1 plus 9 is equal to 20, and 10 plus 13 is equal to 23. So now the question comes, we would have done this iteration only once and checked if the bit is set, then we have done this operation only once, but we cannot do it only once, because there can be other combinations where this can be created with minimum moves. That's why we are doing this binary search, just guessing each time. Now if the remaining number is not 0, then the answer doesn't exist here. In that case, we will delete this part. Now the low becomes here and high is there. Now we'll make this iteration once again, and if the remaining number is 0, that means the answer exists here, but we have to check is this is the minimum combination. So we are taking the minimum of answer and mid. So this is the binary search. After this, we are checking if the answer tends to infinity, that means that we have never met this part. That means the answer doesn't exist. The answer is -1. Else the answer is answer +1. So this is my code which got accepted. Let me submit it once again. You see, this is the correct answer. So if you have Thanks for being there for a long time. If you have any doubt regarding this problem or regarding my solution, you can comment in the comment section and I will try to reply instance. Thanks for watching this video. Goodbye.